The closest planet to the Sun is Mercury. Mercury is hardly any larger than our Moon. On its close orbit, Mercury zips around the Sun in less than 3 months. When Mercury appears close to the Sun, this is what we see from the Earth. As soon as Mercury appears on the horizon, the Sun rises almost simultaneously and lights the atmosphere. Mercury immediately disappears in the blue sky. When Mercury appears furthest from the Sun, it's an hour and a half ahead of the sunrise. Now's your chance. If the eastern horizon is clear with no mist, you can catch a glimpse of Mercury before the Sun comes up. But Mercury moves very fast in its orbit. 1 week later, it will be swallowed again by the Sun's glare. And we'll have to wait for 4 months before it's once more in a position where we can see it. It takes 3 months for Mercury to travel around the Sun and reach this point. During these 3 months, the Earth will have covered a quarter of its orbit. Mercury will take another month to overtake us and reach this point where we can watch for it early in the morning. Mercury, gripped strongly by the nearby Sun, has no moon. Neither does Venus. Earth, the third planet, has 1 moon, of course. Mars has 2 satellites, Deimos and Phoebus. Phoebus was knocked about in a cosmic collision. Further from the Sun, Jupiter is surrounded by 16 satellites. You can see the 4 largest with a pair of binoculars: Ganymede, Callisto, Io, and Europa. Further away still, Saturn has a wide array of satellites, large and small, neighboring its spectacular rings. The Earth has only the Moon as a satellite. The Moon shows us one side, always the same. So, if we always see the same side, why all these different crescents from night to night? The side of the Moon which always faces Earth is lit by the Sun differently from day to day. Just after the new moon, it's practically backlit. When we see the half moon, the moon is lit from one side. Now the moon moves through the second quarter of its orbit, facing the Sun more and more directly, and showing us an ever-growing portion of its sunlit half. It's now almost the full moon. On the eve of the full moon, at sunset, the moon is just above the horizon. Then, as it continues its journey around the Earth, it lines up with the Earth and Sun, facing the Sun. Now it rises just as the Sun sets. It catches the Sun's rays full on. On the night of the full moon, it reflects the most light towards the Earth. Whether crescent or full, the moon always turns the same side towards us. This isn't so for the Earth and Sun. As the Earth rotates every 24 hours, it turns all sides to the Sun. Seen from the Sun, the Earth has no hidden side. The Moon is linked to the Earth, whose mass is much greater. In the Earth-Moon pairing, it's the Earth's pull which prevents the Moon from spinning freely. Its movement slowed, it always shows us the same face. The same thing happens to little Mercury. The enormous sun prevents Mercury from turning freely. In space, between neighbors, it's mass that rules. If you look at the full moon in winter, you'll see that it rises very high in the sky, while the sun, as always in winter, stays quite low. Why this difference? It has nothing to do with the moon. It's our movement, the movement of the Earth, which changes everything. Seen by an extraterrestrial, the moon is lined up with the sun, more or less on the same plane as the Earth and planets. For us on Earth, our frame of reference is the zodiac. Against this backdrop, we locate the stars, the planets, and also the sun and moon. The Earth is tilted in relation to the zodiac, so during the day, the sun appears low on the horizon. At night, we look in this direction, and now the moon appears high in the sky. During the day, like this. At night, like this. The Earth rotates at an angle. Seen from the Earth, it's the zodiac that tilts and seems to undulate. At noon, the sun passes low on the horizon. At midnight, the moon passes high in the sky. But the zodiac's undulation is simply the effect of the Earth's movement.